Hi everyone, my name is Tristan Vanthielen. I'm the head of machine learning at Devoteam G-Cloud Benelux, and I'm here today to talk to you about Flycs, which we call a data warehouse accelerator for GCP. I'm going to focus mostly on the technical side today, looking at the customer case, what issues it solved, and how we got to the solution specifically. Then I'll highlight a bit how it works, the different components involved. Should be an interesting session, so thank you for joining. So, the agenda for today, I'll start with a customer intro. How can a framework look like on GCP? What components are involved? How does it work conceptually? And what specific use cases are we actually solving? So let's start with a customer case. Customer case for Flycs is Randstad Group. So Randstad Group is the #1 global HR company. They work in more than 30 countries. And they started using GCP for all their data-related projects. Now, being such a big organization, working with GCP, of course, there are some challenges in making sure everyone is up to speed. So that's where our problem statement comes from. Randstad really wants to empower all their different countries to implement their own data warehouse on GCP. But to do that, every OpCo or country needs to have a deep knowledge of networking, data engineering, DevOps, basically all different domains that you normally touch on GCP in order just to get started. Whereas the ideal case would be that their data engineers can just get started right away, don't have to think about anything. Everything follows the best practices set out by the organization, and they only have to solve every problem once. So that's really where a framework can come in handy, where it can solve all these issues, and that's what we did with Flycs. So Flycs, it's a framework for data warehousing on GCP, and the idea was that it would be reusable by all different opcos, so they can all work in a similar fashion. All provisions should be automated, so all infrastructure that's being deployed, all the networking, everything, according to organizational policies. This framework should then be easy to roll out to new countries. Data pipelines should be able to be developed just by the opcos. So no one from the global organization needs to be involved there. They have full ownership of their different data pipelines, their data warehouse model, everything. Standardize the tooling everywhere, so it's very easy to get onboarded. If you come from a different country, different project, the tool stack will be exactly the same, so it's very easy for you to understand what they're doing. On top of that, using this tooling, we can then embed some different solutions for specific problems that don't only have to be solved once, which is very, very useful. So how does that look on a high level? Well, on a high level, this is what a normal data project on GCP looks like. Most traditional companies have some kind of relational database as their source, sometimes a NoSQL database, sometimes a bit more unstructured data. But the idea is get everything into GCP, whether that's cloud storage or BigQuery, doesn't really matter at this stage. There's change data capture as an example here, but that can also be a dump, where data just lands in the raw data area. In there, data is mapped as is from the source. There's no guarantee that we can keep that forever. So we want to move that to the data lake environment. The data lake is where we keep all our data historically. We will not change it, but we make sure it's ready for long-term storage. From there, we can kind of explore the different use cases we want to solve, and we decide on a data warehouse model that we want to achieve. That model is based on the business concepts we have. For Randstad, for example, you can imagine they have talents, they have job openings, that kind of stuff. How do they relate? Do we want to use data vault, more Kimball style dimensional modeling? That's up to the opco to decide. In between the data lake and the data warehouse area, traditionally there's a staging area, which is kind of the scrap space for data engineers to make sure that they can have a bit of temporary storage in between their different transformations. It's not meant to do any insights on. Really, the end goal for the staging area is to make the data warehouse layer as clean as possible. Then in the data warehouse, we have all our data nice and modeled. We again have the full history, but not every tool can exploit that easily. That's where data marts come in. So in data marts, we will provide specific subsets of the data, maybe pre-aggregated, something like that, for use by different serving layers. So on the right, you see serving layers, just some examples. They're your traditional dashboarding tools like Looker, Data Studio, but also machine learning, data flow if you want to send your data somewhere, Jupyter notebooks for data scientists that want to do some exploration, doesn't really matter. Those can have specific data marts created for them, or data marts based on domain, something like that. On top of that, on top of BigQuery, it's very important to have a good data governance layer that really helps the business know what data is there, ensure qualitative data, that kind of stuff. That's where GCP provides a data catalog to keep a catalog of your data that can be tagged. It really integrates very well with BigQuery out of the box. So that's another tool that's being integrated in the framework. Now, in order to move data across these different stages, we need an orchestrator or something that actually does the transformations. And in this case, that's Airflow running on Cloud Composer, the GCP managed service. We'll highlight Airflow a bit later, but it's a very nice tool. And then we have the traditional stuff like Cloud IAM, Stackdriver, or Cloud Monitoring, as it's now called, to set up the full monitoring suite on GCP to ensure that whenever a new opcall starts, they have monitoring, they can easily configure alerting. It all comes out of the box. Now, another thing I want to highlight, this picture you see here, that's one environment. So every opcall will have their own production, acceptance, dev, test environments. And the idea is we want to replicate as much as possible. The source data can be different. It's best practice to not use your full production data in test, for example, but the stack should be exactly the same. So that it's very, very easy that if we have something working on test, we can promote it to acceptance and promote it to production. So this picture, keep it in the back of your mind, it's replicated across those different environments, and it's totally isolated per country or operating company. Now then this slide, that's really the only salesy slide I'll include today. The idea is that then these different opcalls can start working immediately on Insight. So that means doing their own data transformations, the SQL transformations that get them to their data model, get them to their data marts that they can use. And they don't have to care about how they're going to orchestrate it, how will they version everything, monitoring, how will they deal with PII, how do they test it. That's all standardized within the framework. What components are involved here? Well, I'm going to go very quick at the start because we've already discussed some in length. Of course, Google BigQuery, it's the backbone. It has a lot of different integration options. It scales very, very well, and it will solve most data warehouse use cases on GCP. Cloud Composer, I promised I would go a bit deeper. It's based on the open source tool called Apache Airflow, where you can define directed acyclic graphs using Python. Directed acyclic graph basically means you have a sequence of tasks or data transformations that happen one after the other, and there cannot be any cycles within that sequence. That's how we will define our data pipelines. But actually, Airflow, it's a lot of knowledge you already have to have, whereas the idea is we just need people that write SQL. That's our target audience. So we kind of abstract away Airflow on top. Then we have GitLab, a version control system, very, very good for storing versioned instances of our different data pipelines. And GitLab also has a nice feature in the fact that it comes with its own CI system. GitLab being fully open source means it's very easy to include that in a framework, host it once, reuse it with different opcalls. We'll see that later. Then we have Spinnaker. Spinnaker, a bit more of a niche tool, very, very powerful, especially with workloads for Kubernetes, but it's a deployment tool that we use for deploying the data pipelines to GCP. So there's a very clear separation between GitLab, which is the CI, continuous integration. It does all the testing, preparing the data pipelines for deployment, but Spinnaker does the actual deployment, and that's also where developers will get the final say if they want to proceed with the deployment, yes or no. Terraform, very, very popular tool. Won't go too much into it today, but it's an open source tool for doing infrastructure as code that's multi-cloud, very powerful, declarative. So you say, what do you want to have? And Terraform is responsible for getting you there. But it's also a great place for enforcing your security policies. And then, of course, Google Kubernetes Engine. It's used for running most of the workloads described here. It's one of the big powerhouses on GCP, just like BigQuery is. And it's being used to host all these different services. So how do these kind of fit together? Let's start again with this high-level picture here. This is what we want to achieve. But the first problem we discussed is, okay, how do we actually move across these different environments, right? So for that, we have a CI/CD process set in place. In application development, that's called DevOps. In this case, it would be called DataOps. But that's basically GitLab and Spinnaker working together to form a CI/CD flow to deploy our data pipelines. Those applications are hosted only once, centrally for the customer, and they can then enable that service for their different countries. So every country is a different group on GitLab. They're logically isolated from each other through access management. They work completely independently. But if you're a developer that has access to Belgium and France, you just have to go to one GitLab instance and you will see both there. You can easily work on them. From there, the CI/CD process needs to actually map to specific projects from that country. So that's what we see here. I know this is a lot of different projects. It's really as granular as you can go. In here, every stage that we had before, for every environment, so dev, test, acceptance, production, is a separate project. And then we have multiple data marts, again, separate projects in this case. All these data projects, normally you have to manage access there so that your cloud composer can pull data across, all that kind of stuff. You have to manage these data sets. That's all done for you by Spinnaker. Okay, so then let's go to GitOps. GitOps really is the only point of contact for developers with the framework. It gives a very clear structure, way of working. In application development, yeah, that again maps to DevOps. In here, we have 3 protected branches by default: DevOps, release, and master. Develop, release, and master, sorry. Those are mapped to the test, acceptance, production environments. So whenever something is pushed to master, that will trigger a production deployment. In Spinnaker, you can still verify that and give a manual go, no-go. But on top of that, whenever you go on a feature branch, you will be totally isolated from all other developers. So if I'm working, a colleague of me is working, we can work on our data pipeline. It's totally isolated. And then on develop, we can kind of merge the work that we've done. That really allows us to work very agile and very quick. So this is what that flow looks like. I've explained it quite a lot. So we go from GitLab CI to Spinnaker and then to the target project based on the branch. So what use cases do we now solve? Well, this CI flow here allows us to actually modify the data pipelines that have been submitted. So we can insert some specific things here that really allow data engineers to progress with their work a bit quicker. One of them is, of course, time. This really allows you an iterative process that lets you work very quickly, which is the best way for your data engineers to provide value to the business. There's a lot of replication and consistency. Why every country is working in the exact same way, very easy to switch context in between them and know exactly what's going on. And they're all according to organizational policies. But the exact use cases that we mentioned before, such as handling PI data, I'm just going to zoom in on that one right now. So one example is the right to be forgotten, where someone can call and say, okay, hi, I want you to forget all my data. And that's something that companies now have to deal with. In order to enable that, Flycs uses something called crypto shredding, which is a very good first step for your right to be forgotten process, where a data owner tags all sensitive data for a specific concept. So for example, talent or the data set he's responsible for. And Flycs will automatically encrypt all the data that comes from there inside of all your different data layers, maybe up until the data mart where you actually want to present the data. Every user has their own key set that's used specifically for them. If they don't want to be forgotten, we remove the key set. We cannot decrypt their data any longer, and it's a very, very good step to forgetting all their data. So the process, data stewards or data owners can fill in tags on Google Sheet, always get approved by data owner, and from there it can go to data catalog. That's also something that comes with the framework. It's deployed automatically. And what does that look like within BigQuery? So within BigQuery, let's say we have a raw table here where we have the ID, first name, and age. A data engineer just wants to write a SQL statement like the bottom right here, select 3 columns, first name and age are PII, but he shouldn't care. So what Flycs will actually do, it will transform that SQL statement to go and look at the key sets, encrypt this information automatically. And if we write the same SQL statement again, but go, for example, to the data mart, and we say, I want you to decrypt it here, it will do that automatically as well. This allows our data engineers to transform the data however they want. It happens automatically. And this is just one example of what you can do when you have control of the full CI/CD process and can inject these kind of transformations in there. On top of that, we provide full field level lineage. Again, that's extracted from the SQL that's written in a very similar process, but that allows people consuming the data to trace back data all back to the source. Those are really the most important use cases that we mentioned at the start, on top of everything being very easy to redeploy at different countries. I hope that was a very brief and good introduction to Flycs. I hope you learned something from it. I hope you can pull it to your organization. Again, if you want to contact me, here's my details. Thank you for joining the session.